You know, there's this idea on the nature of choice, an idea that's plagued me often once I heard about it, and I'm going to infect you with it too. In a little bit, we're going to look at how computers make decisions, and how, given the same input, the same data to look at, it always makes the same choice. You could do it 100 or 1,000,000 times, and it'll always do the same thing. But this makes me wonder about people. Do people always make the same choices? If you end up in the same place, with the same memories and the same environment, and given the same choice, do you always make the same decision? Is what you output the same always, given the same information you receive as input? Any media on time travel certainly requires this determinism. The model only works if all 8 billion people do the same dance they've done before, the only change being the small ripple you've entered into the system. The small change in input, the flip of a bit, and the system of people adjusts accordingly like a machine. So then, the natural question to beg, do we have free will? If your brain always makes the same choices given your world, then what choices do you really make? Anyway, here's a program that estimates the number of attendees for a concert. You're an event organizer trying to slot in artists into the right venue. This first, naive version of the program just estimates that double the number of people who previously attended the last event will attend this one. This gives a safe margin for very small artists, since if you have 15 people show up for one event, 30 for the next isn't too hard to imagine. But for bigger artists, this can be way overkill. So you looked at concerts in the past and figured out a good rule of thumb, that actually, for most concerts, it makes sense to just assume that the same number of people will show up for the next one as they did previously. But only when less than 40 people showed up does it make sense to double it. This means we want our program to make a decision, to assume the estimated attendees is the same as the previous attendees, but to double it when the previous attendees are less than 40. This is where the if statement comes in. If statements say execute the code in here, between these two braces, but only if the condition between these two brackets is true. A condition looks like this. This one says if previous attendees is less than 40. So when we run our program and enter a number of 12, when the program gets to this if statement, it checks what the current value of previous attendees is, which is 12, and compares it to the 40. Since, yes, it's true that 12 is less than 40, we enter the if statement and set our value of estimated attendees to 2 times the previous attendees. That's what gets printed out at the end, 24, which is double. Now let's rerun our program again, but enter in a number that's not less than 40, and see what happens. When we get to the if statement, the condition evaluates to false. It's not true that 100 is less than 40. So we skip over everything inside the if statement and jump right to the print line, which just prints out 100, the same number we entered. We haven't explicitly talked about this, but you can change a variable's value as many times as you want by assigning new things to it. The value is just whatever was last assigned to it, depending on where you are within the running program. So back in our attendee code, we assign our variable twice. First, to be equal to the previous attendees by default, and then this line optionally overrides it, changes it to double, but only if it's allowed to run, which is when we have less than 40 people. Let's take our program to the next level. From the data you observed for big shows, when there's a lot of excitement, our calculation is too conservative. If a show is sold out, it's a good idea to add a little bit more room next time so more people can attend. So if it's a big show, then we should check if the previous show was sold out. And if it was, we should add a quarter more people as a buffer, allow for 25% more people to show up. else will let us have code that only runs when we don't enter our if statement, when the above condition is false. In this case, when it's not a small concert. So inside, we can ask the user to enter in 1 if the last show was sold out. Like before, if a number less than 40 is entered, we double it and print out the doubled result. The else doesn't matter here. But if a big number is entered, our false condition makes us jump to the else block, and we ask the user if the previous show was sold out. We haven't done anything with their answer yet, so let's fix that. We want to add a buffer only when it's sold out. This means we need another if statement, where inside we're going to add our extra buffer like this. For our condition, we ask the user to enter in 1 when the show was sold out. So we want to check when the value inside of our isSoldOut variable is 1. If isSoldOut is equal to 1. We can write that like this, with 2 equal signs. Why 2? Well, C doesn't want to guess when you want to assign or compare. A single equal sign means take whatever is on the right side and put it in the variable on the left. Double equals asks a question. Are the left side and the right side the same? True or false? So now we have 3 possible paths our program can take. If the user says there were 2,000 people, we ask them if it was sold out. Then we check if our isSoldOut variable contains a 1. In this case, yes. So we enter our if statement and add in our buffer. So we get 2,500 people instead of 2,000. But if we reran with the same number of people, but said it wasn't sold out by entering 0, 0 isn't 1, so we don't enter our if statement, and we keep our original estimate of 2,000. And lastly, we still have our small concert case, which simply doubles our estimated attendees, and nothing in the else block matters. Now we got a pretty good tool to estimate how many people are going to show up. We just need to choose an adequate venue. Here's the venues that we have. Each has different capacities. We need to pick a venue that can fit our estimate, but we don't want to pick a venue that's too big. That would be a waste. The goal is to select the smallest venue possible that can fit our estimated people. If we start checking the smallest venue first and work our way to the largest, the first venue we can fit in will naturally be our closest fit. Let's implement this algorithm in code. We'll start by adding variables to represent each venue size. Then we check if our estimated attendees fits into our smallest venue, echo forage, like this. You'll notice that we have variables on both sides here, instead of a number on one. When there's a variable, C will happily look up the current value of the variable, no matter which side of the comparison it's on. For our next venue, Velvet Lounge, we want to check if we can fit, but only if we don't fit in Echo Forge. Given what I've shown you so far, we can do that like this. And this works fine. If we fit inside of Echo Forge, we'll print it out. But if we don't, check if we fit in Velvet Lounge instead. But this heavily nested code will get messy and hard to follow if we keep adding stuff deeper and deeper within our else blocks. So instead, if you have a solo if within an else, C lets you collapse this into an else if statement, which means the same thing. If we can fit in Echo Forge, print Echo Forge. If not, check if we can fit inside of Velvet Lounge, then print Velvet Lounge. Then we can chain on else if cases for each of our venues. And if we want, an optional else at the end, which is executed if no other block is entered. Our program will only enter one of these. It'll check each condition in order, one by one, and then enter the first whose condition is true, or the final else block if none of them are true. Okay, let's test our entire program one last time and see how it all fits together. We're planning for an upward trending band. 260 people came to see them last time, and it was sold out. This means we're going to account for 325 people this time. Our program then searches for a good venue fit. The first two were too small, but Hollow Pub will do. So our program prints out hollow pub and ends the program. I've shown you these comparison symbols so far, but there's a few others you can use. For all of these, on either side, you can put numbers or variables. Let's quickly walk through the ones I haven't shown you so far. We looked at the double equals for checking if two values are the same, but we can also use exclamation equals for not equal. For example, since dividing by 0 causes your device to spontaneously implode, it's a good idea to protect yourself and others by checking for 0. Here, we do the division if the denominator is not 0, if items per box is not equal to 0. Otherwise, we print an error. We used less than, but as expected, there's also greater than, asking, is the left side greater than the right side? For both of these, you can stick on an equal sign to the end for or equal to. So greater or equal to, less or equal to. For example, here in this program, it checks if the temperature is greater or equal to 100. If you enter 100 or a number greater than 100, it prints out that water is a gas. If you enter a number below 100, but greater than 0, it'll say it's a liquid. Any other temperature will say solid. Even 0. Since 0 is not greater than 0, we go into our else. You have to be careful when choosing between whether you want the strictly exclusive greater less than or the inclusive greater less or equal to. There's technically a minor bug in our venue code here. If our estimate came out to exactly the size of our venues, we choose the wrong one. Like here, our estimate comes out to exactly 300 people. For 300 people, we'd want to choose Velvet Lounge, since it can fit 300 people. But our program chooses Hollow Pub, which is too big, since 300 isn't strictly smaller than 300. We need to switch each of our conditions here to be less or equal to fix this. Let's start making some programs with decisions. There's some experiments on codeaesthetic.io for you to try out if you need some ideas. Otherwise, you should try to come up with some of your own examples to practice and lock in the concepts. It's your choice. Or maybe your brain has already decided for you. Based upon this input. Does more input change the outcome?